Hi guys, it's me again. This is a little crazier. I'm going to try and go through a problem, and the number is problem number 3, or problem from chapter 3, 27A. We're going to try that. You're going to hear some more birds and dogs and whatnot, but we're going to try and go through this so you can see it kind of going on live. Hopefully you can read this when it's all up online. Anyway, this is about a pharmaceutical company that manufactures an over-the-counter allergy medicine. The company sells both large commercial containers of 1,000 capsules to healthcare facilities and travel packs of 20 capsules to shops and airports, train stations, and hotels. The following information has been developed to determine if an activity-based costing system would be beneficial. They've listed out activities. There's material handling, packaging, and quality assurance. They've estimated indirect activity costs by activity, so the costs that are associated with that activity, and the allocation base for each one of those activities. So, and then they give us other production information, units produced, weight in kilos, machine hours, and company samples for commercial containers and travel packs. First thing we need to do is compute the cost allocation rate for each activity. So each activity, we've got 3 of them. We've got materials handling, I hope you can see this, and that is a silky dove if you're wondering. Okay, materials handling, the indirect activity costs were $115,000, and the allocation base was the number of kilos divided by 23,000 kilos. So I'm turning on my calculator. 115,000 divided by 23,000 equals $5. $5 per kilogram. That's materials handling. Packaging. So as you can see, this is very similar. Very similar to what we did with the just general the allocation of overhead to everything. Packaging was $204,000, and its allocation base, or cost driver is another way they state it, is based on machine hours, and the total machine hours is 2,125. 2,125, and that's machine hours. So we take 204,000 and we divide it by 2,125. That's $96 per machine hour. The last one is quality assurance. Quality assurance is $118,000. Is the indirect costs of, associated with that, and samples is the cost driver, and it's 2,000 samples. So 118,000 divided by 2,000 is $59 per sample. Okay, so that's the first requirement for this problem. So there'll be something similar to this in the homework. The second problem, or the second requirement, says use the activity-based cost allocation rates to compute the activity cost per unit of the commercial containers and the travel packs. And it says, hint, first compute the total of the commercial containers, first compute the total activity cost allocated with each product line, and then compute the cost per unit. So we've got to deal with commercial containers, and I forgot to set a timer. Okay, commercial containers. We have units produced. We have 2,400 units produced. And our weight in kilos was 8,000. So we have 8,000 units, 8,000 kilograms, times, from up here, $5 per kilogram. So 5 equals $40,000. The second thing was packaging. And machine hours were 1,500. So we have 1,500 machine hours, and we have up here $96 per machine hour. So we take 1,500 times 96, and we get 144,000. And number of samples was 200 for this one, times the $59 per sample. So 200 times 59 is 11,800. Add these. 40,000 is 195.8. Okay, that's our total costs. But I'm running off the edge of the video. Divided by the total number produced, 2,400, gives us $81.58 per unit. Okay, and that's containers. So that's the first part. We do the same thing for travel packs, and if we go through the numbers, we have weight in kilos is 6,000, and we have the 6,000 times $5 gives us 30,000. We have machine hours of 500 times 96, that gives us 48,000. And the number of samples was 300 for quality assurance, and that times $59 per sample gives us 17,700. The total for travel packs was 95,700, and the number of travel packs was 41,000. So you take the 95,700, divide it by the 41,000, and you get $2.33 per travel pack.